Hey everyone, Mr. Ahmed here. I thought I'd make this video to help you guys prepare for your upcoming Chantier Calcul test, which is happening next Tuesday on January 23rd. Now, this is the answer key to the Sujet Zero. I highly recommend that you go and actually do the Sujet Zero on your own first, prior to looking at my answer key and prior to watching this video. So let's dive right in. So for this very first example right here, you've got negative square root of 5 plus 5 square root of 5 minus square root of 5. So remember that these square roots of 5, you can actually consider them as variables. You could even think of them as an x, right? So you could say minus x plus 5x minus x. Okay, well, minus x plus 5x is 4x, and then 4x minus x is 3x. Okay, it's not x, it's square root of 5. Well, there you go, you get 3 square root of 5. Okay, looking at this question right here, well, when you've got an exponent like this outside of parentheses, remember that this exponent is going to apply to everything within the parentheses, right? It's going to apply to the 3, and it's going to apply to the square root of 23. So that means you're actually going to say 3 to the power of 2, which was what we do here. And then here you have to think of it as, okay, well, I've got square root of 23 to the power of 2. Well, I know that raising something to the power of 2 is the opposite of square rooting. So actually what ends up happening is that the square rooting and this to the power of 2 cancel out. They're actually opposite operations. So you end up with just 23. Same thing happens over here. You've got 2 to the power of 2, and then you've got 23 on this side. Now, this comes out to 9 times 23 minus 4 times 23. Again, if you think of 23 as being a variable, that's the same thing as saying 9x minus 4x. Well, what's 9x minus 4x? Well, that's 5x. Okay, it's not x, it's 23, so 5 times 23. Well, 5 times 23 is 115. Okay, let's move on to this question right here. So when you look at something like this, you have to say you have to be thinking, order of operations. What is the most important operation here? Well, you've got a pair of parentheses and you've got multiplication. Well, we know that we have to evaluate what's in the parentheses first, because according to PEDMAS, parentheses are more important than multiplying. And so when you've got two fractions like this and you're subtracting them, you have to make sure that they have a common denominator. That means these numbers down in the denominator have to be the same. Well, 5 and 7, what is the least common multiple of those two numbers? So take a second to think about it. Well, that number is 35, right? So 5 times 7 gets you 35, and 7 times 5 gets you 35. Okay, well, if I'm taking this guy and multiplying it by 5, then I better make sure that I'm multiplying the numerator by 5 as well. And that gets me 25. And notice this negative right here is right here. Now, this 5, in order for it to reach 35, I have to multiply it by 7, which means I have to also multiply the numerator by 7. Well, negative 3 times 7 is negative 21. Now, be careful here when you're doing this subtraction. Remember that you are actually starting at a negative value, so minus 21 minus 25. Now, I know a lot of you guys are, or maybe not a lot, but some of you guys are thinking minus 4, and that's wrong, right? We are starting at a negative value. We're starting at negative 21. So negative 21 minus 25 is negative 46, okay? So I've got negative 5 over 12 times negative 46 over 35, and here's where I start splitting my numerators and denominators into their prime factors, right? So I separate 12 into 2 times 2 times 3, and I separate 35 into 7 times 5. I can't separate negative 5, or I can't separate 5 at all. It's a prime number. However, I can separate 46 into negative 2 times 23. And so I'm noticing that I can actually cancel out the 2 with the 2 down here and the 5 in the numerator with the 5 down here. Now, I also notice that I've got a negative happening here, right? So this is a negative value times a negative value. Well, a negative times a negative is a positive, so my negatives are gone. So all I have left in the numerator is 23, and all I have left in the denominator is 7 times 2 times 3, which is 42. Looking at this question right here, well, I split my, first things first. What's most important to do according to BEDMAS? Well, is it division or subtracting? And it is division. right? So division is more important. So what I'm going to do is I'm going to first of all split 72 and 72 into its prime factors and 289 into its prime factors as well. Well, 72 is 2 times 2 times 2 times 3 times 3, and 289 is actually a perfect square. It's 17 times 17. Okay, now I can change this division into a multiplication, right? And then it becomes 17 over 24, but I'm going to take that 24, I'm going to do the same thing to it as I did to 72 and 289, which is factor it and break it down into its prime factors, right? So 24 is 2 times 2 times 2 times 3. Okay, so now I've got this stuff all nicely laid out like this, and I can start canceling things out that appear in the numerator and in the denominator. So for example, the 17 is going to cancel out with the 17, the 3 is going to cancel out with the 3, and I notice that I've got 3 2's, so I'm going to cancel out these 3 2's as well. So all that's left in the numerator right here is 3, and all that's left in the denominator is 17. So I've got 3 over 17 minus 1 over 17, and that gets me 2 over 17. Okay. Now here you're being asked to calculate the volumes of these shapes. Now remember that when you've got a 3D shape like this, the volume of this kind of shape is just going to be the base area times the height, right? So when I look at my base here, it's a triangle. Okay, now it's also a right angle triangle. Notice that there's a right angle right here. So that tells me that this triangle has a base of 4 and a height of 3, right? Or you could also look at it backwards, where this 3 is actually the base and this 4 is actually the height of the triangle. Doesn't matter, either or works. But here's the deal. When you have the base of a triangle and you have its height, the formula to calculate its area is going to be the length of the base times the length of the height divided by 2. So you're going to go 4 times 3 divided by 2, and that's what we do here. That's the area of your triangle. Now remember, you have to take the area of the triangle, or the area of the base, and multiply it by the height. So you're going to take 3 times 4 over 2, which happens to be 6, and then you're going to multiply it by 7. And that gets you 42 centimeters cubed. Okay, to figure out the volume of this composite shape, what you're going to do is you're going to figure out the volume of each shape individually, and then you're going to add the two volumes together. Okay, now the volume of a rectangular prism like this is going to be 3 times 2 times 1.5, right? So length times width times height. Well, 3 times 2 is going to be 6, and then 6 times 1.5 is going to be 9. So that's what we get over here. And then this guy right here is a triangular prism, right? So here what you're going to do is you're going to figure out the area of the triangular face, and then you're going to multiply it by the distance through which that triangular face repeats. You're kind of doing the same thing here as we did here. Right? You take the area of the triangle and you multiply it by the height. Okay, well here I'm going to take the area of that triangle and I'm going to multiply it by this length right here. Again, the distance through which that triangular face repeats. Okay, well the base here is 2 and the height is 1. So the area of this triangle right here is 2 times 1, which is 2, but then you divide it by 2, right? So base times height divided by 2 is the area of a triangle. So 2 times 1 is 2, divided by 2 is 1. Okay, so this guy right here is 1, the area that is, times 3. So 1 times 3 is 3. So that's what we get here. So 9 plus 3 is going to be 12, and that's the total volume of this shape. And then finally, for a cylinder like this, you're going to do the same thing as we did here. You're going to be doing the base area times the height. Well, the base area of this guy, the shape at the bottom, this base, is a circle, right? So the base area is pi r squared, which is the area of a circle. You're going to go pi r squared times the height. Okay, well, pi times r squared, that's 4 squared. That means this area of the base is 16 pi. Then you're going to multiply by 25, but they are asking you for exact values, so all you're going to do is you're going to go 16 pi times 25, and you're going to multiply the 16 by 25 and get 400. So your answer is going to be 400 pi. Okay, now here they're asking you to express these guys using scientific notation. Oh, sorry, my apologies. They're actually already in scientific notation, so they just want you to express them in decimal form. So here what you've got is you've got 4.01 times 10 to the negative 1. Now when you've got a negative exponent like this, that tells you how many times this decimal has to move to the left, right? First of all, when this is negative, your decimal is moving to the left. When this is positive, your decimal is moving to the right. Now here I'm going to be moving to the left by one spot. So my decimal is moving to the left by one spot. So it's going to move right in front of the 4. And so I get 0.401. Now here, same thing. This guy's going to be moving to the left 4 times. So you're going to be moving to the left once, twice, 3, and 4 times. Now this is what you get. Again, remember, this guy right here was originally between the 2 and the 3. So you can actually see that it's moved to the left 4 times. It was originally right here, so check this out. 1, 2, 3, 4. Okay, now another way of looking at this kind of question is just to consider this as being the number of zeros that precedes the 4. So here, for example, you're going to say, oh, I've got 1 0 before the 4, so 0.401. Okay, now here you could also think of this as being, oh, well, I've got 4 zeros before my 2. So then that's going to be 0.000. There's 4 zeros right there. And then you write the rest of this value, 231. Okay, now this guy right here is positive, which means that my decimal is going to move to the right. And it's going to move to the right 2 places. So one place brings it after the 5, and the second jump brings it after the 6. So this becomes 456. Now here we're being asked to take these values and write them using scientific notation. So when I want to write these guys in scientific notation, I just want to make sure that my initial value right here is going to be a value between 1 and 9.999, right? So to do that, I just have to kind of move my comma in the proper direction so as to get a value right here that is again within that interval, right? So for instance, I'm going to take a look at this comma and I'm going to say, well, how can I move this comma to make it so that this value is a value between 1 and 9.99? Well, let's check it out. If I move it to the right once, that's not enough, right? I'm at 0.3. But if I move it to the right twice, I'm now at 3.3, right? So I'm at 3.301. Okay, so then that means that I have to move this guy to the right twice, right? Now, that means I'm going to be doing 10 to the power of -2. Okay, now that's one way of looking at it. The other way of looking at it is just to count the number of zeros that precede the value, right? The actual value here being 3. So you look at the number of zeros here and you say, okay, well, how do I get, well, you just count the number of zeros. You just say, okay, that's going to be 10 to the power of, -2, right? So hopefully that kind of makes sense here. Again, you're trying to make it so that this comma is here, right? So moving on to the next question here, you've got 112,000, right? So you're trying to make it so that this comma right here, right, ends up being between the 1.12. So then you have to ask yourself, okay, how many times do I need to shift it over? Well, you need to shift it over once, twice, 3 times, 4 times, 5 times. So you end up getting 1.12 times 10 to the 5, okay? Now this guy right here, I need to shift it over a single time. And so then I have to write 3.401, and because I shifted it over only one time, then that means that's times 10 to the power of 1, okay? So hopefully that stuff makes sense there. And then finally we'll take a look at this, and I think this little bit right here, I'm just going to leave that to your French teachers to explain it to you. And also, I know they've taught it to you in a certain way, so just kind of make sure that you're following the ways that they've outlined for you to do these conversions. But let's take a look at this last section here together. So here you've got find the slope and intercepts for the following line equations. So y equals 2x minus 1. Okay, now you'll remember that this was one of the very first things that we saw together, right? This thing right here, like these are obviously linear equations that are in slope-intercept form, okay? Now, slope-intercept form is this form, mx plus c. And you'll recall from our classes together that c is the y-intercept and m is the slope. So as long as your equations are in that format, y equals mx plus c, you're actually going to be able to read the slope and the y-intercept straight from your equation. Okay? So here, when it's asking you what's the slope, well, that's 2, right? It's m. And when it's asking you what's the y-intercept, well, that's going to be c's value, which is -1. Okay? So that's the slope, that's the y-intercept. But then you have to ask, okay, well, what's the x-intercept? Well, the x-intercept means where your line is going to cross the x-axis. Now, wherever your line crosses the x-axis, the value of y is always going to be 0, right? Because you haven't moved up and you haven't moved down. And so the value of y is going to be 0. So for instance, this right here could be, just giving you examples of coordinates. This could be like 5, 0. The next point over could have been 4, 0. The next point over can be 3, 0, 2, 0, 1, 0, 0, 0. The point after that could be -1, 0, -2, 0, -3, 0, -4, 0, right? And so on and so forth. Okay? And you'll notice that the constant thing about any point on this x-axis is that its y-coordinate is always 0. Well, luckily for us, equations are input-output machines, which means that I can ask my equation, hey, equation, what's the value of x when y is 0? So that's exactly what you do. You substitute y equals 0 into this equation, and you solve for x. And that's what I do here. Okay, so I substitute 0 for y, and I solve for x. Okay, so 0 equals 2x minus 1. Now, when I want to isolate for x, make sure that, again, when you're isolating for variables, you're doing the reverse operations of BEDMAS. So you're starting by getting rid of any adding and subtracting before moving on to any multiplying and dividing. Okay, so what you're going to do is you're going to add 1 to get rid of it on this side, and that means you're going to add it on that side too because you want to maintain that equilibrium. That gets me 1 equals 2x. The second and final step here is to divide by 2. So you're going to divide by 2 on the right-hand side, and you're going to divide by 2 on the left-hand side. So that means x equals 1/2. Okay, and maybe before I move too quickly here, just to clarify why I divided by 2 here, it's because the operation happening between this 2 and the x is a multiplication, right? This is 2 times x, which is, the same as x times 2. So I get rid of times 2 by doing the opposite operation, which is dividing by 2. And I better make sure that I do that on both sides of my equation. That way I maintain that equilibrium. Okay, so that leaves me with x equals 1/2. Okay, now I'm not really sure how it works in French math, but in English math, when we're asked for y-intercept, you're totally okay saying, -1, or you can also just write the coordinates of the y-intercept, okay? Either or is fine. I would recommend that you just double check with your French teacher to see what their expectations are in this regard, okay? Same thing for the x-intercept. Okay, let's move on to the second one here. Now this is y equals 4x. Now notice that there's nothing after it, right? That term right here is missing. That means that that term is actually 0. So that means my y-intercept is 0, okay? My slope is 4. It's the number in front of the x. And then my x-intercept, well, I just do the same thing I did up here. I replace y with 0 and I solve for x. 0 equals 4 times x. So then 4 times what gives me 0? Well, 4 times 0 gives me 0, therefore x equals 0. And it kind of makes sense too, right? Like that's something that kind of makes sense. If your y-intercept is 0, right, that means that your line is crossing the y-intercept at exactly 0, right? It's crossing that y-intercept at 0. Well then, that logically means that it's also crossing the x-axis at 0, right? So that's kind of how that works out. So anytime you get a y-intercept of 0, just kind of bear in mind that your x-intercept is always then going to be 0 as well. Okay, y equals 5x minus 2. This guy's already ready for you. The slope is 5. It's the number before the x. And then the y-intercept is the number that's on its own right here, which is -2. Okay, we do the same steps that we did for the previous two equations for the x-intercept. So here what I'm going to do is I want to figure out what is the x value when y is 0, right? So I replace, in my equation, I replace y with 0 and I solve for x. So then that means the first step right here is going to be to add 2. So I'm going to add 2 on both sides. Okay, so I'm going to get 2 equals 5x. And then the last step is going to be to divide by 5. So I'm going to divide by 5 on the right-hand side, and I'm going to divide by 5 on the left-hand side. Now, remember that left-hand side had a 2, so then that's 2 divided by 5. So x equals 2 divided by 5. Okay? Now, the final equation here is a little trickier. And the reason it's tricky is because it's not yet ready in y equals mx plus c form. Notice that here you've got an x, whereas all the other ones were in the proper slope-intercept form, meaning y equals mx plus c. This is not in y equals mx plus c, so what you're going to have to do is you're going to have to convert it to y equals mx plus c, and the way you do that is by isolating y. Okay, so you isolate y in the same exact steps as what we did here, which is we're going to get rid of this subtraction first, before moving on to getting rid of any dividing or multiplying. Okay, so here I'm going to be adding 1 on both sides, so I get x plus 1 equals 2y. And then I'm going to be dividing by 2 on both sides. Now when I divide by 2, I make sure I better divide by 2 on every single term. Okay, so 2y divided by 2 is just y. X divided by 2 is 1/2 x. And 1 divided by 2 is 1 over 2. Okay, so here's my equation in slope-intercept form, in that y equals mx plus c form. From that, I can see that my slope is going to be 1/2 and my y-intercept is going to be 1/2. Okay. In regards to your x-intercept, you're going to do the same things. You're going to replace y with 0. Now you could do that in this equation and solve for x, but notice that it's actually a little easier to do that in this first equation, right? If I replace y with 0, then here I have 2 times 0 is 0, and 0 minus 1 is -1. Okay, so then my x-intercept here is -1. And as I've said before, I'm going to let you guys kind of go over this stuff, using the notes that your French teachers would have given you, or the way that they taught you to do these conversions. All right, guys, I think that's it. Good luck on your Chantier Calcul.